In this video, I will guide you through a problem in Smith's Organic Chemistry. I'm Stoddard, founder of Study Chem, the place for students to turn for higher grades in OChem. Let's get started. Problem 36 here asks us to draw the products from these reactions, including stereochemistry. There's a lot of wedges and dashes here. The first step to think about is what kind of functional group do we have? We have an epoxide. Epoxides react with nucleophiles. Is this reaction condition acidic or basic? It's basic. So we know that under basic conditions, the nucleophile will attack the less substituted carbon atom. And that means at this stereogenic center that it's attacking, there's inversion. So let's go ahead and draw the product here after nucleophile attacks and protonation by water. So as I mentioned, the top stereogenic center does not undergo inversion. It's not being attacked. So keep the methyl group on a wedge there. Keep this oxygen on a wedge. It's going to change to an OH group. Down here, we want to have the nucleophile attack from the back side of the molecule and add in all of the atoms and groups and branching or whatnot that you might have. So there's oxygen with the CH2 group and with the CH3 group. And this is where you do the inversion. This, well, we won't draw the hydrogen. Okay, so this used to be a wedge, now it's on a dash. Second problem, we want to think about the same thing. Epoxides react with nucleophiles. Is this acidic or basic? This is a basic nucleophile. It's R minus. And this carbon here is more substituted. It's connected to two carbons. And this carbon's connected to one carbon, so it's primary. So what we'll have is this nucleophile attack from the opposite side as the leaving group, which is this oxygen. So what we want to do is keep all of these wedges and dashes the same here. We'll keep the two carbons in the middle here, and we'll go ahead and add all these in. So we have that CH3 group here going on a wedge dash. We have this hydrogen going on a wedge, and over here we want to flip things up a little bit. We have a hydrogen on a wedge and a hydrogen on a dash. Okay, this oxygen is going to be bonded off in the upper left-hand direction. So we draw a line to the OH. It gets protonated after the nucleophile attacks. Okay, it gets protonated. Then where do we draw this R group? We draw it coming down from the bottom right, and that's going to be an alkyne. I'll go ahead and draw the carbons here. So in this top problem, because we're drawing the ring kind of flat, we want to switch the wedge and the dash. Now because the oxygen is not on a wedge and a dash here, we want to just draw the nucleophile attacking from the opposite side of the molecule so that we don't switch any wedges or dashes here. All right, thanks for watching.